computer-aided cervical cancer diagnosis using time-lapsed colposcopic images. Here is the introductions. This cancer is basically it is a type of cancer that occurs the lower part of the uterus of a woman. It is the fourth most cancer-related death worldwide. And the motto is early detections of this cervical cancer can significantly increase the survival rate of the patient. That is the motto over here. In this paper, we propose a deep learning framework for a accurate identification of LSIL, which is low-graded interepithelial lesions, including CIN and cervical cancer. Using time-lapsed colposcopic image, by using those images, we are going to predict that cancer rate. The proposed framework involves two main concepts: key frame features encoding network and feature fusion networks. The features of the original image and the colposcopic image captures at around 60, 90, 120 and 150 seconds durations at the acetic acid test and encoded by the feature encoding network. Here is the advantages. Over here, deep learning framework for LSIL, which contains CIN and cervical cancer diagnosis by fusion images for multi-time slot. Previously, it was single time slot. Here, it is converted to multi-time slot. Early detections of the disease. Here we can find it so earlyly, means at the 0th level we can find it that that patient will affected by the disease or not. The method uses deep learning network to extract features from each of the colposcopic image of a patient, and it will find it with a more accuracy. Your descriptions. The goal of this project is to detect the abnormal growth of cell by comparing all the colposcopic images to find the accuracy, to detect the disease in the earlier stage based on these images. Here, the one instrument will insert through the lower part of the woman, and that instrument will go inside it, and it will capture some images. During, as I discussed earlier, 60, 90, 120, 150 seconds, that durations, it will capture some images. After that, we will briefly analyze those images and we will predict that cancer is there or not. This system involves mainly three steps. The first one is cervix detections, feature encoding, and GCN-based feature fusion. Here is the architecture. As I mentioned, in a three-step process, it will go through. First thing is cervix detections. Here we can see from colposcopic images, we are assuming that which part of the cell is being affected and all. And second thing is feature encoding. And third thing is GCN-based fusion. Here feature encoding, if I will say, the original pre-acetic acid images, these are original pre-acetic images which are clicked at 60, 90, 120 and 150 seconds after the acetic acid. The colposcopic image at a different time slot contains something information. The capture images are proceed by individual feature encoding networks, simply these things. And here GCN based fusion, it will convert to one safe to identify easily that there is positive or negative. It's basically about that. Here, one normal thing, here I have used almost all the same libraries which are used in normal ML and DL problems like Pandas, NumPy, Matplotlib and Sklearn. But one important library is called Keros. This is one of the library which is used to code deep learning models. Basically, it is its backend is used backend is user TensorFlow. TensorFlow is basically, we can say it is an open source framework developed by Google researchers to run machine learning and deep learning. Here is my use case diagram. One user, firstly it will importing modules, collecting data, means images, that colposcopic images, pre-processing images, convert into one size, converting image into pixel for a better accuracy, creating deep learning model, feeding the converted pixels to model, and finally predicting the results. Here is the class diagram. User has to log in into it, and module has to import, and as right side you can see image. We are going to extract features of before that we have to pre-process those images, and after that we will extract features from each colposcopic images, convert image into pixels, models, predict database, and predict the output. Finally we will going to get the result. This is sequence diagram. Here user is importing a model, collecting data, pre-processing those images, and converting image to pixels, creating deep learning models, and feeding the converted pixels to model, and predicting the result. Here is the activity diagram. Here is my algorithm. Firstly, at first, importing all the modules, then a large scale data set containing time-lapsed colposcopic image is collected, then pre-processing all the colposcopic image for a better accuracy, so that we can get maximum accuracy. Training and validating our deep learning framework. Dataset is provided to the network called GCN. GCN is Graph Convolutional Network. This is for image processing and all, GCN. The system will pass through three step process, as I mentioned earlier: service detections, feature encoding, and GCN based feature fusion. The proposed deep learning framework achieves a classification accuracy. By consisting the accuracy, the system will provide the result either positive or negative, and it will store the data in the database. Thank you, sir.